Today I'm going to talk about LeetCode question 424, longest repeating character replacement. So given a string s and an integer k, you can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Okay. So for example, with this guy, k is equal to 2, we can replace either both b's with a, because 2 b's, or either both a's with b, uppercase b, and we get maximum length 4. Okay? And with this one, k is equal to 1, so we can only replace one uppercase character with another uppercase character, okay? And then we have to count the longest substring containing only the same letter. So for example, here we can replace this middle A here with B, so we get B, 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 and we get maximum substring length of 4. Okay? So yeah, how could we possibly go about it? So a brute force way is focus on one character. So if you have A, B, A, we'll look at the second example, A, B, A, B, B, A. So like focus on one character, iterate through the rest of the string, and count how many times a character differs from our character in focus. So we have A, okay, great. We have B, okay. So our diff count equals to 1, okay. And then we have A here, and then, which is great, and B, but since we already changed this B to an A, we can't change this B to an A because the number of character changes we can do is 1, okay? So we stop our iteration there. And right now we have max 4. So now, if we have our next character in question, this A here, next focus, then we iterate through the rest of A. So we have B here, diff count 1, okay, A, B, but we already changed this B. So we stop the iteration there. We see that this length is 3, but 4 is greater than 3, so we keep 4 as the answer, and so on. This is O of n squared, but we can do better using the slide-in window approach. So I can explain how. So with the slide-in window approach, we have a start of our window and an end of our window. And so as long as the condition is satisfied, where we haven't done more than k changes, we keep increasing the window, okay? So our start-in window is here, okay? So we keep increasing it. Oh, this is different. So we have our count diff to be equals 1. And continue and continue. But unfortunately, we have our count diff to be 2 here because of this B, and what we're looking at is A. Why are we looking at A? Because simply this is the most number of characters in our window so far. So with this most number of characters, we're just assuming that any other character that is not A has been changed. Okay, so now our count diff is 2 because of this B. So what we want to do is start decreasing our window until it's equal to or less than k. So we decrease it from the left. So A here, okay, and now count diff is still 2 here, so we decrease this guy, okay, and now we see our count diff is at 1. Why is that 1? Because B is the largest character in question, and we only have the A here, so we simply converted this A to a B. So we have 2 B's plus 1A, which equals to 3 characters. Okay? And also, so 3 total characters minus 2 of B's equals to 1 different character. And this different character is our K here. And since this number of different characters is less than or equal to K, we're good. And this is basically how we're gonna go about it. Okay. Okay, so how we're gonna go about this is initially we have our window here, and then we're gonna increase our window. Okay, and then as we're increasing our window, what we're gonna do is keep track of the total length of the window, right now which is 2, subtracted by the dominant character in the window, which is right now A, and there's 2 of them, and that equals 0. So this 0 represents the number of characters we have changed to match the dominant character. So right now it only consists of 8. And then we move our window along here. So now our window length is going to be 3. And since A is still our dominant character, so that's going to be 2, and then the total, and then we get 1. So 1 represents us changing one of the characters, which is B in this case, to match the dominant character 1. Okay, and then we continue, and then once we get here, this is the interesting case. So now we have length 5 minus dominant, which of A, and there's 3 of them. And there's 2. So actually, now in this window, we have done 2 operations to match dominant character A, but we're only allowed 1 operation here. So what we have to do is, while 2 is greater than 1, what we have to do is decrease our window until this guy here matches or is less than K. So we're going to decrease our window by 1. Okay, and we have this, and then we continue. So you might be wondering why are we continue expanding our window if we have AB here? We have 2 operations now. We have 2 operations now which we've done to turn it into dominant character A. So like if we have these 2 B's, we have to do 2 operations to turn them into A, and we're only allowed 1. Well, if you think about it, so before we expanded our window, we had A, and so our max was 4, okay? And then we went to maximum of 5. We found that the number of, we had to do more than K operations, so we decreased our window here. And now our length is 4, okay? So our string, when we have is never gonna exceed the maximum of 4 here. Our window, even if it contains letters where we have to do, more than K operations on it, it will never exceed the maximum that we calculate if we have characters where we've only done K operations. Okay, it just won't happen. You can try it out yourself. So for example, here we have this guy, and then we expand our window here. Okay, and then we again, now the dominant character is B, our length is 5, so 5 minus 3 is 2, and so we decrease our window here. And notice how it's still 4. It will never exceed, our proper string that we calculated, where there's only k number of operations done. Okay, and then similarly here, we've done k equals 2 operations, so cut this out, and our length is now 4. Still not exceeding the proper one calculated of 4. Okay, so it will never happen to exceed it. Okay, now to code this up, so I want to have my result first of all, initially at 0, and then I want to have my start window position, which is initially going to be at the beginning of the string 0. Okay, and now we're going to have a char frequency array. S only consists of uppercase English letters, so we can initialize that to of length 26. Okay, and this will take care of our dominant, the number of characters that we've seen so far. We can get the dominant number here easily. So for end window in range and so we have our start window pointer here, and through this iteration, this is going to take care of our end window. It's going to be our end window pointer. Okay, so what we're going to do is s at the position end window is going to be, or not at the position end window, forward. It's easier if we separate it out. So our character here is going to be S. Our character at this position is going to be here. And then we're going to increment the value in the array, or char minus ord. Okay. And that is going to equal that plus 1. Okay. So basically in our array, it's going to be all capital letters. So at position 0, it's going to contain number of A's. Position 1 of this char frequency array, it's going to be at number of B characters, etc. Okay. And then our dominant char number is going to be the max of char frequency here. Okay. And our changed, how many characters we've changed, our is going to be number of characters our window so far minus dominant. Minus dominant China. Okay. So, and also what we're going to do here is while changed is greater than k. So if the number of operations we've done exceeds the k we're allowed, what we're going to do is shift our window to the left. So it's going to be like, minus word char is equal to okay, and then we're gonna decrement that because we're moving our window. Okay, and then shorten our window and decrease that. Okay, and finally, after all that, our result is gonna be equal to maximum of itself and the current window size. End window minus start window plus 1. Okay, and finally, result. Okay, that looks good to me. Oh, this should be start window. So, and this is gonna be O(n). This is linear time, O(n) time. So, for end window and range length of s. Okay, increment the count there. Get the dominant character frequency. And then calculate the number of operations done, and if the number of operations exceeds k, then we shorten our window. And yeah, okay, I'll try testing it out here. Oops, should be start window. Okay, and we can try one again. Okay, great. And I'll try with the rest of the test cases. And I'll submit. Okay, great. Thanks for watching.